Bienvenidos, Ushamdi, and welcome CTS-131, Section 875 students for the Spring 2018 semester at Anne Arundel Community College. This is the Routing and Switching Essentials version 6 course, or the Networking 2 course at Anne Arundel Community College. And this afternoon's video tutorial and solution set is going to be on our chapter number 2 skills activity, where we're going to take a look at configuring some static routing, and then we're also going to be configuring the RIP routing protocol. So let's go ahead and dive in and take a look at the topology that we have. As you can see, this is a little more complex than what we typically deal with. We've got router 3 over here by itself, and it has a point-to-point serial connection over to router 2. And then router 2 takes us up to router 1, and router 1 connects us to our internet service provider. Now we have 2 connections to the internet service provider here, right? So we're going to be doing, I believe, a floating static route. So let's go ahead and dive in. And part 1, configure static default routes on router 1 and router 2 only. So on router 1, let's go ahead and open up the dialog box here. And we'll go to the CLI where we're in user exec mode as evidenced by the greater than sign. We'll type the enable command to get into privilege exec. And then we're going to get into global config with configure terminal. So on router 1, we're going to configure an IPv4 default route. Well, we know that's the quad zeros, right? So we have 2 sets of quad zeros. Remember what that means is that says my route to any network in the IPv4 space that I do not have a longer specific match for, right? If I don't have more specific routing information, this is my catch-all, my safety net. And we're going to do a directly connected using serial 000. And as we would anticipate, we see that ubiquitous message that constantly comes up when we use an outgoing interface that says default route without gateway, in other words, next hop IP, if not a point-to-point interface, may impact performance. But that is not a concern here because these are the serial links are point-to-point interfaces. So we are good. Now on router 1, we're going to configure an IPv4 floating static route to go out interface, and this is where the up arrow comes in very handy, serial 001 with an administrative distance of 2, right? And so the concept behind the floating static route, when we look at the diagram and the topology that we're dealing with here, let me get the pen tool up and running, and we'll go with green since red is already here for the serial links. So this is router 1 right here, and router 1 has 2 ways or 2 serial connections that it can use to get to the ISP, right? And then as we get behind the ISP, this is the big bad internet out here. So we've decided that serial 000, that is going to be our number 1 exit interface. That is our primary path out to get to the internet. We are now creating what's called a floating static route, right? With a higher administrative distance. And what that's going to do is it's going to sit, and think of it like this. It's kind of on standby, waiting for that link to go down. And as soon as this link goes down, that floating static will be auto-magically inserted into our routing table here. And I probably shouldn't draw the arrow from router 2. But it'll be auto-magically inserted into the router 1 routing table. So that way we then just simply come across that link. So let's see what that looks like. In fact, we'll down the link as well, and we'll see which route gets installed in the routing table. And if you're looking down in the lower right-hand corner, you can see that we just picked up our second set of 10 points. So when I say do show IP route, we see a single static route, right? A single candidate default route, which is a static route that we've created. And it says directly connected, and we've created as directly connected. Those were the instructions that we were given, as well as for our floating static. But where's the floating static route? Why is it not showing up in the routing table? Yeah, because the static has a default administrative distance of 1. If I were to say do show run, And let's come down to where we've got those routes. What we've done is that last argument there, if I were to pull this back and do a question mark here, the distance, right? And remember, lower with administrative distance, lower is better. And so by default, it's 1. By us putting the 2 in there means that it's not going to get installed into the routing table, because the routing table is only going to install the same route. If there are 2 of the same routes and one has a lower administrative distance, that will be the one that is chosen to be placed into our RIB, that routing information database, commonly referred to as the routing table. Now, let's check this out. Let's see if this works. We don't have connectivity all the way out to the ISP yet, but there's an easy way to see. Do show IP route. Whoops. Do show IP route. So again, we see that the interface serial 000 route is in here, and you can put extra zeros in there. It's not going to affect it. That's why I have the 2 zeros. I don't backspace because it doesn't matter. So I'm going to shut this interface down. So we shut down interface serial 00. Now, when that interface goes down, what's happening behind the curtain, right, behind the scenes, is that when I say do show IP route, now take a look at who's been inserted into the routing table here. Exactly, it's our candidate default out serial 001 that simply had a higher administrative distance than the static default that was in there before we shut the interface down, and the router is going to remove that entry from the routing table, because if the interface is down, the router understands I have a static route, a default static route, currently pointing to this outgoing interface. That interface has been taken away, therefore I'm removing that route from the routing table because I know that I can't send traffic out that interface. The interface, if I say do show IP interface brief, the interface is down, and we can see that right here. So our floating static works. Always good to configure or to validate after you configure that something works. So now we bring serial 000 back up. What do you think happens? Do we still have the outgoing interface of serial 001 for the static default? Or is the router smart enough to realize, hey, the interface out which I have a static default route with a lower administrative distance, the default administrative distance for static routes of 1, is it going to reinsert that into the routing table? And that's exactly what it's going to do. And the router is smart enough to go ahead and make that change. All right, so that takes care of the floating static, and we even validated that the floating static works and does what it's supposed to do. On router 2, we're going to configure an IPv4 default route using the next hop IP, and you even get a little hint right here, right? It's the serial 011 IP on router 1, which is, I think it's 10.10.21. Now, does it make sense to put a static default route here? Even though it's going to be a recursive entry, is it still something that we should be doing? Absolutely, because we only have one path to get out of our network. And again, we'll put this as the little demarcation point here, right? Remember, this is the big bad internet over here, the ISP. There is only one path for me to follow to get out of here, right? If I'm router 2, I have to go to router 1. So this is a use case where it makes absolute perfect sense to say, yeah, let's do a static default route. And we're going to go ahead and make it a recursive static default route. So I'm going to say IP route. And again, it's a default route. Let me make sure that's right. Yeah, default route. So the quad 0 is IPv4. And what is my next hop going to be? Well, it's going to be 10.10.20.1, and that is router 1. Now, we're not doing any kind of a floating activity here with this static route or with this default route. So all we need to do is run the command as we would typically run it for a static default route. So that takes care of step 3 under part 1. And you can see we had 30 points at risk, and we nailed it. We got all 30 points. So now we're going to transition here to part number 2. I'm going to pull that back just a skosh. All right, so we're going to come to part number 2, configure a static route on the R2 networks, or to the R2 networks on router 1. So this is a 10-pointer. Some low-hanging fruit right here. So let's come to router 1. And what are the networks over here? Oh boy. All right, so we've got 2. They're going to try to make it a little tricky for us. So they've got 2 /25s. I'm trying to adjust the window here. 2 /25s. All right. So on R1, configure an IP4. Oh, actually, I'm sorry. We're just going to send all of our traffic down there, which we can do because 225s, these 2 /25s right here, just happen to be the same /24. Basically, the /24 was cut in half to give us these 2 /25s here. So all we need is a static route, and this is going to be a directly connected static route. So we're going to say IP route to get to the, so my route to the 10.10.16.0 /24, which is 255.255.255.0, is out the serial 011 interface, and we should pick up 10 points, and we do. All right, now we get into configuring RIP, an interior gateway routing protocol. The first real interior gateway routing protocol. In fact, you used to be able to run RIP on Unix boxes back in the day. That is really where RIP got its start. All right, so on router 2 and router 3, we're going to configure RIP using the following parameters. Let's get router 2 up here. So we are going to use version 2. So the first thing I need to do is to get into the RIP configuration mode. And it's very simple. You just simply say router RIP. And as you can see, it puts me here into the RIP configuration global config section. And we've got some options that we can use here. Now, on router 2, what are we doing here? Advertise the directly connected networks only. Be sure to remove any extraneous networks. And I'm going to work forward here to see what that is referring to. Configure passive interfaces for the LAN interfaces. Now, that's easy to do, right? So, and we don't even need to see the interfaces because they're up here in the diagram. Gig 00 and 01. These are LAN interfaces. So we're going to go ahead and say passive interface, gigabit Ethernet 00. And then we're going to say passive interface, gigabit Ethernet 01. And what does that mean to make an interface passive, right? It's great to know the command, but what are we talking about when we make it passive? That means that RIP is not going to be sending routing updates out those interfaces because, again, nobody down here on this diagram, nobody else down here speaks RIP, right? So to send that RIP traffic down here is simply a waste of resources, right? And it's also a security concern because you don't want your routing domain information being flooded around the user portion of your network because users are very creative. They can sniff that traffic. They may find out what RIP information is being shared and try to get into the RIP routing domain by inserting a nefarious device of some kind. It could blow your routing up. So that's why we passive these interfaces, because it's not required for anybody down here on these interfaces to receive RIP packets, RIP routing updates. All right. Whoops, sorry about that. Okay, so we did the passive interface, and then version 2 is the first thing that we're going to do. There were 2 versions of RIP, RIP version 1 and RIP version 2 with IPv4. There is a version for IPv6. It's called RIP-NG. It stands for Next Generation RIP. All right, propagate the default route on R2 so that R3 will automatically get it. All right, so in RIP, in order to take the static route, the static default route that we've already created on router 2, and to allow RIP to share that with the routing process, we simply say default information originate. And once we come over here to router 3, we'll see that we're automagically, via the RIP routing protocol process, going to pick up that default route. And now we start to kind of see the underpinnings, the beginnings of why the dynamic routing protocols are very, very desirable when we start to add multiple routers in and we've got a dynamic routing protocol running. It's definitely an advantage over static routes. All right, so we've got the, well, we need the do show IP interface brief. All right, so I need statements to advertise the networks here on this router. Now I'm wondering if what it's looking for, and it doesn't mention anything about auto summary. Let's see here. So if I was to say network, and I think that's, we have a 172.16. So if I was to say network 172.16.0.0, and then network 10.0.0.0, is that what it's looking for? And I'm looking to the right. Yeah, so it's going to take that. So auto summarization with RIP, right? That option that you have there says auto summary. It's going to, when I put those network statements in, it's going to basically treat those as they're classful, as they're supposed to be classful, right? So in other words, anything that's a 10 network is going to be advertised, right? I'm advertising one huge 10 network, and the same is true of the 172.16.0.0, right? Now the 10, as you can see, we've got subnets down here, right? So, but we're just simply saying that, hey, any 10 network come to me. And that actually works because 3 doesn't have a 10 network over here. And that'll get into a larger discussion that I'm sure we enter into, which is that variable length subnet masking and discontiguous network segments. All right, so we're okay with that. Now, is that everything? Propagate the default. It looks good. Let's get router 3 up here, and let's get RIP running on router 3. So we'll come to the CLI. We're in user exec because of the greater than sign. We type enable to get into privilege exec, configure terminal to get into global config. Router RIP, the first thing we want to do is say version 2. And let me squeeze this down. There we go. All right, advertise directly connected networks. And so it looks like it's going to let us get away with this, 192.168.1.0. Let me hit enter and see, and yep, we got the point for that. We did the version 2 and passive the LAN interfaces. Gigabit 00 should be passive. And then propagate, so we should have the default route. The LAN interfaces are 3. Oh, and the last thing, and I almost forgot, very important, forgot the last network statement there, 172.16.0.0, right? And we need that not only to get that last point, but also to make sure that we are communicating between these two routers with RIP. If I don't enable the process here on that interface, right? And really that's what these network statements are doing. Let's talk about that for a second. So when I type that statement in right there and I hit enter, what immediately begins to happen is the RIP routing process on that interface is now sending RIP packets on the interface. In fact, this is a great opportunity we just happen to have, and you don't, whoops, sorry, you don't want to see the firewall there. Let's go back. Where's router 11 at? So here on router 11 that we configured the other day, if I go into global config and I say router RIP version 2, do show IP, whoops, do show IP interface brief. All right, so I've configured it, and we're not going to passive any of the interfaces. So here's what I'm going to do. I'm going to say do debug, and actually I'm going to have to take a look here at the context-sensitive help. So I'm going to say debug IP. I think you can do debug IP RIP. I don't use RIP a whole lot. I use OSPF and EIGRP and BGP on a day-to-day basis. All right, so we're just going to say debug IP RIP, right? So let's get into global config. Let's go back into router RIP, and let's say network 10.0.0.0 and hit enter. So by me entering in that command, and in fact, I'll even put in the, I'll say no auto summary, and let's actually do this. I believe it's 10.0.0.0, 0.0.255. Whoops, and I actually can't do that. Sorry about that. Yeah, so we've got that. I want to get the, what was it, 11? What is the 11, 11, 11, 11. We'll put the loopback address in here. 11, 11, 11, 11. And do show IP interface. Whoops, IP interface brief. And that, I apologize. So this is now what's happening. You can see that we've enabled the RIP routing process on the interface, well, in the config, and what that does is on any interfaces that fall within this network, in other words, our, what is it, gigabit, yeah, our gig 00 interface here. So on that interface, even though the interface is in a down status, take a look at what we have here. We have updates that are going out. So RIP updates are getting sent out, and you can see, and actually because the interface is down, they're not going out that interface. They're actually trying to go out the loopback interface. I had forgotten that interface was down. So we take a look here though, and look, RIP uses multicast. RIP version 1 used broadcast, and that was even worse. But take a look. RIP version 2 uses multicast, and this is a reserved, well-known multicast address, 224.0.0.9, that's being used here to send these RIP v2 updates out. And this is how RIP works. So let's say that somebody was on the other end of the loopback address, which they're not, right? Because the loopback address is this router. But if someone was on the other end, they would get the update packets. If it was a router that was running RIP, it would say, oh, hey, well, I speak RIP version 2 as well, so let's exchange some packets. And yes, there are ways to interoperate with version 1 and version 2, but those are way outside the scope of CCNA. So anyway, there you go. That is what happens when you enable RIP. And on the interface where RIP is up and running, and I don't think we have, I should have probably looked here first, Debug Ip Rip. Huh. Packet tracer surprises me here, right? So we can do debug IP rip with packet tracer, and what we're going to see, and there it is, right? And this would have actually been a better way to show you. I apologize. I was not hopeful that this was going to be working. And take a look here. We received a RIP update from who? Yeah, from router 2. And what is in that update right there? What's that? That's that default route that router 2 sent to me. So if I say show IP route, there is the candidate default route. Whoops, the candidate default route with the administrative distance of 120. That's for RIP, right? Oops, sorry. And then you can see the metric is 1, and RIP uses a hop count for a metric. And we see the R that stands for RIP. And so now you can see we're getting these updates. So the last thing that we're going to do is we're going to come down here to this PC3, because I want to see, can I get all the way out to the big bad loopback interface on the ISP router. So let's ping 64.100.100.1. And my guess is we may have to miss a packet or two here while it sorts its way out through the network. And we got all the points. And let's see what's happening here. All right, so it doesn't like that. My guess is yeah, we can't get to the ISP, so it's locked. I can't see if the ISP knows how to get back to us. And on router 1 here, can router 1 even ping that address? Let's see. My guess is, if I was to say ping 64.100.100.1, okay, it works from router 1. Let's try from router 2. Ping 64.100.100.1. And it works from router 2. Does it work from PC2? And again, not part of the activity, but it would be nice to validate ping 64.100.100.1. All right, so now we got a question here. So it works from PC2. It works from PC3 is my guess. Ping, 64.100.100.1. And so did I typo it here? I don't think I did. 64.100, .100.1. Okay, we didn't. So let's troubleshoot. Let's see what the problem might be. So I'm going to close that window down. Let's come in here to the config. All right, I've got my default gateway. We have the route out. The question is, does router 1, let's see what router 1 has, show IP route. So this is the first problem I see. Does router 1 know how to get back to the 192.168 network behind router 3? We never had to create a static route for that. We put the static route for that where? Here on router 2. Oh, I'm sorry. In fact, router 2 knows about that network via the RIP process. So what we could do is we could run RIP here, or let's see if we can solve this here. Let's get into global config, and I'm pretty sure this is what we're missing. 192.168.1. What was it? 1024? Yep. .1.0. Whoops. .1.0. So my route from router 1 to get to that /24 network behind router 3 is to go out serial 0, 1. We'll do it directly connected. 1, 1. There we go. Now let's come back over here to router 3, and first let's say do show IP route. And there's my static, right? So I know how to get back there. Oh, you got to love it when a plan comes together. All right, so if you were looking at this activity, and actually take a look at that. Did we miss that? Were we given information on router 1? I don't think we were. Maybe I missed it. But yeah, so from the PC3 command prompt, oh, okay, I'm sorry, ping the internet IPv4 address. So that is not an internet IPv4 address. That doesn't match these other, that's the internet 64. So, okay, I think I know what this activity might be doing. The 10.10.16 is over here. In fact, who is 10.10.16.126? That's PC1. So maybe this update needs to, this would have worked, right? The reason it didn't work to the 64.100, which is ultimately where we want to get, right? We want to be able to go out to the internet. So let me close that down. I'm sorry, you know what? I ran that on the wrong box, didn't I? I certainly did. I apologize. So I ran that on the wrong PC. So here we are back on PC3. And the request is timing out. And it looks like it's not going to get back. So here's what I bet the issue is that this ISP has a route in it to get to the 10 networks, but not to the 192.168. But again, I apologize. I can't get on there. The config is locked. So yeah, I think what this router up here needs is a route back to the 192.168. And so that's why when we do this, ping 10.10.16.126, that's going to work, but that's not the internet address of 64.100.101. So I apologize for that false alarm there. But yeah, there was routing information that was definitely missing from router 1, but there's also routing information missing here at the ISP. At least that's my guess, but we can't get in there to see. So we've got our points. We've got everything done. This is going to wrap up Packet Tracer Activity, Chapter number 2, Skills, where we did a little deeper dive into some static and dynamic routing. We even got into configuring the RIP routing protocol. All right, well, thank you so much for watching, and I will talk with you soon.